Okay, in this video, we are going to be talking about what isomers are. So this is section 14.3 in the organic chemistry unit. So this is just an overview of different kinds of chemical formulas. So the first one you should already be familiar with is called the molecular formula. So this is just showing the number of atoms that each element of each element in the compound. So something like C2H6. The structural formula is going to be more like a diagram of what the shape of the compound actually is, and it shows what atoms are bonded to what and things like that. And then lastly, we also can have the condensed structural formula where each carbon is written separately followed by atoms bonded to it. Okay, so all of these are C2H6. Okay, which is also ethane. Okay, so all of these are examples of ethane. They're just written in different ways. So the molecular, structural, and the condensed structural formulas. So isomers are compounds that will have the same molecular formula, but they will have different structures, and thus they can also have, or they will have, different names. So different structures or different structural formulas. So even though two or more molecules can have the same number of each atom, they can be arranged in different ways, which makes them different molecules. Okay, so that's what isomers are. So they have the same molecular formula, but different structural formulas. And because they have different structural formulas, okay, they're not bonded exactly the same. That means that isomers have different properties or different characteristics about them. Okay, they're not the same thing, so they're not going to behave in the same exact way. So here's the first example. We have 1 bromopropane and 2 bromopropane. So if we were to count all the atoms in each, let's start with the 1 bromopropane. So we have 3 carbons, 7 hydrogens, and 1 bromine. Okay, so for 1 bromopropane, if we wanted to write the molecular formula, we can write C3 for the 3 carbons, H7 for the 7 hydrogens, and then 1 Br for the 1 bromine. Now, if we were to compare 2 bromopropane, we have 1, 2, 3 carbons. We have 1, 2, 3, 4, 5, 6, 7 hydrogens, and again 1 bromine. So this is going to have the same exact molecular formula. Okay, they're both C3H7Br. Okay, but they are not going to be built the same, or their structure is not going to be the same. So for 1 bromopropane, the bromine is on the first carbon in the parent chain, whereas for the 2 bromopropane, the bromine is on the second carbon of the parent chain. Okay, so they are different structurally, or they have different structural formulas. Okay, so here's an example of 3 isomers of pentane, which is C5H12. Okay, so pent tells us that there are 5 carbons in that parent chain. And it also tells us that, because it says ane, that they are all single bonded. Okay, so this is what pentane would look like, okay, down here on the left. So we have that 5 carbon parent chain, and then just it's filled, or it's saturated rather, with all of these hydrogens. And the carbons are all connected by single bonds. So that's just what a typical pentane would look like. And that's having the formula C5H12. Okay, but now it's saying that 2-methylbutane and 2,2-dimethylpropane are isomers. Okay, notice how they look completely different. They have different names. They don't have the same number of carbons in their parent chain, okay? But let's just take a look a little bit closer into how many of each carbon and hydrogen both of these molecules have. So starting with the 2-methylbutane, let's just count our carbons. So we have 1, 2, 3, 4, 5 carbons. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. So 2-methylbutane is going to have the same molecular formula as the pentane. Now let's just check the 2,2-dimethylpropane. So counting the carbons, 1, 2, 3, 4, 5. Then the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that one's exactly the same too. So it has the same molecular formula. All of these different molecules have the same number of carbons and the same number of hydrogens. However, they're all going to be arranged differently, giving them these different structural formulas. Okay, a different arrangement of their atoms. They're bonded in different ways. Okay, and because of that, they're not going to behave exactly the same. Okay, so again, isomers have to have the same molecular formula, but they're rearranged in a different structure, and therefore will have different properties. So this is another example of 1-butene and 2-butene. So because they have the same number of carbons and hydrogens, but their arrangement is different, they both have the carbon-carbon double bond on different carbons in the parent chain. So these would be an example of an isomer as well. Okay, this is a non-example of an isomer. So looking at these, we have both of them have a 3-carbon parent chain, okay, which is prop, prefix prop. And all of them are a single bond, so we would label that propane, okay? But notice how for both of them, they still have the same exact structure. Even though this one is written where this carbon just goes down, they still have, the carbons are all aligned, and all of those carbons have hydrogens. So this is a non-example, they would not be isomers because they are the same exact thing. Okay, they have the same molecular formula as well as the structural formula. Okay, they have the same arrangement of their atoms. Okay, here is another one. It's saying that the top two are the same, but the bottom two are different. So let's look at the top two. So again, we have a 3-carbon chain with single bonds, so that's propane. And then each of them have a chlorine group, okay? The rest are filled with hydrogens, and then they each have a chlorine attached to one of the carbons. Now, if we were going to label this one, we always start by labeling our parent chain with, so that the group is the lowest number. So we make this carbon 1, 2, and 3. And then the same thing would go for this one. So now we make this carbon 1, 2, and 3. Okay, so they're going to have the same molecular formula, but they're also going to have the same structural formula, the same name. It's just kind of flip-flopped. So both of these have the chlorine on the first carbon of the parent chain. Okay, so they're both going to be the same exact thing. But if we looked at these bottom two, okay, this one on the left is the same example that we just looked at with the chlorine on the first carbon of that parent chain. Okay, but this one has chlorine on the second carbon of the parent chain. Okay, if we were going to label this now. Okay, so this one is 2-chloropropane. Okay, so that is going to have a different structural formula. The chlorine is attached to a different carbon on the carbon chain. So therefore, these twos are isomers.